Hi, folks. I'm showing a Desmos screen, obviously. You've seen these, played with these before. And in fact, what we're going to do is something that we touched upon in the fall. If you remember when we were doing the derivative, playing with derivatives with the graph paper and actually just doing derivative lines on the graph paper and coming up with those functions, the very, very beginning of derivatives. We might have played with Desmos a little bit then, I think. So what I want to do is I want to show you how to program a tangent line to follow a function. So here's a function that I chose, y equals 0.5 x times sine of 2x. All right, so here we have a function. It's a pretty cool looking function. It's got a lot of bounces and waves, and they have change in size and stuff. It's pretty neat looking. So we have this interesting function to follow. Now, if we wanted to just have a dot follow the function, we would start an ordered pair and put in A for our x value. And then for our y value, we would put in the function again, but instead of using x, we're going to replace it with a because x has become a. So 0.5 a times sine of 2a and close our parentheses. And it asks about a slider. You've seen sliders before. We're going to add a slider. And what we have here is as we move our slider up and down, our dot over on this side actually follows the function we have because as the y value is -5, or as the x value is -5, the y value would be 0.5 times -5 times sine of 2 times -5. So we're using the function to locate a particular point. Now remember, a is just a value, while x up here with x and y is all values. So you get this red line because x is taking on all these values, whereas a is taking on the values 1 point at a time. Right? Now what's also cool about this slider is we can change its parameters. We can make it go just maybe from -7 up to +7. And we can have it step by, I usually like to have it step by a small number so it doesn't get too glitchy. We'll have it step by 0.05. And then we can play. And when we play, our dot over here follows along, which is really cool. And it can play back and forth, and there's our other settings for that, but it just plays along. Now, what we want to have happen is we want a tangent line to play with that dot. So that dot's cool, but we also want to show a tangent line. Now remember, a linear equation in point slope form is our easiest thing to do, is y minus y1, not gonna bother to put the 1, equals m times x minus x1. Now we can't use x and x1 though. We have to use, instead of x, we're gonna use a. We're definitely not gonna use m. Let's just leave that out for now, but that's the place we need to put our slope. And then y minus y1, well, again, our y value at any point A is this 0.5a times sine of 2a. I'm just going to actually copy that down to here. So we'll copy this in here. And this is multiplication, so I don't need any parentheses. And lo and behold, our line goes through the point that we've been talking about. If we change our value of a, our line will continue to go through that point, but our slope is just a slope of 1 right now because I didn't put anything in for m. So we want the slope to follow the function. Well, in order for the slope to be the tangent of the line, we want to put the derivative equation in here for slope. So right here, we're going to put the derivative equation. So we need to figure the derivative equation out. 0.5x, we need to start with our first equation here, our 0.5x times sine 2x. And it is product rule. We need to take the derivative of that. So if you want to pause for a second and try that on your own, that's fine. But I did it earlier. And the derivative is 1/2 sine 2x plus x times sine 2x. So I need to put here, where the slope would be, I need to put inside parentheses, because it has a plus sign in it, I need to put 0.5 sine of 2x, except I'm not going to use x, I'm going to use a, right? Because this is our place where we have a static values that go with the slider. A kind of moves because we're programming it to move. Plus, so this is product where we have 0.5 sine 2a plus a, which would be x in your derivative, sine of 2x, except it's 2a. Okay, so the derivative of 0.5x times sine 2x is 0.5 sine 2x plus x sine 2x. But I put that in the position of slope. And what should happen, if we do it correctly, is we should wind up with tangent lines. It looks like I have a mistake because my line is not tangent. So let's see what happened. What happened here? This is working along fine. It's the slope part that's bad. 1/2 sine 2a plus a sine 2a. Plus a sine 2a. All in the slope position. That should be right. Back to the drawing board. Okay, I paused it there for a second because I needed to find an error. So here's what's happening so far. I found the error, but didn't change it. So as we play this, the line is actually not tangent at the point that it's playing on. So I want it to be tangent. So I made a mistake in the derivative. It's 0.5 sine 2a plus a cosine 2a. And now it should work properly. There we go. It's playing a little fast. Let's go a little slower. Let's see, we can slow it down so we can see how it moves nicely. Okay. So the line is always tangent to the curve perfectly. Before, when I had this mistake in it, when I had the sign here, it was moving this way. It wasn't actually tangent to the curve at too many places. But with the cosine in there, it works great. All right. So think about what's happening here. In this equation number 4, we have y minus the basically f of x value, y minus the output of the function at a, equals, then we have the slope of the function using the derivative, again using a, times x minus a. All right. So in order to do these properly, you basically need the derivative and the function. So the function you have, you just have to substitute a instead of x. And then the derivative you need to calculate, and again, substitute a instead of x. And then you let your a play, and it follows the curve. In the packet, in the collaborative packet, there's a few of these to do, and we can do others too. All right, and we'll probably do others as we do the next round of work the next day too.